The objective of this program is to discover the coordinates of projectile motion, x and y. And we know the x coordinate is given by the v naught times t cosine of theta, and the vertical component is equal to y. Y equals v naught sine of theta times t minus half gt squared, and we have some representative values. So let's see whether we can get to a reasonable projectile trajectory. So x and y coordinates will be extracted for the position of that projectile. So this is possible in Fortran. We will take the time value, we will compute x value. This is going to be a sequential execution, like taking a new value of time and then computing the corresponding x and y values. So from the 7th column, I can write program projectile. Projectile is fine. And then the end program, prog, and then implicit now. Then we declare the variables. So real, velocity v naught, and for time, so okay, t for time and theta for theta, and we can define real value g, and we can also define g as a parameter. Okay, that's fine. What else we need? We need the output variables x, y. And then let's define t value equals 0. And what's the time step? So it is required for programming the step size. So let's say it is h. So t is 0. So we can define then okay, t equals 0, and let's define do while t is less or equal to 10. Well, there must be the h defined. H is equal to for example 1. So for t, well, we also required the initialization of other parameters, but these are in our control. We define v naught value. V naught is v o or v0. It should be very clear to you. So v0, for example, 20, and the units are our responsibility. Just as for a specification, it should be there. Theta equals 60 degrees. This is in degrees. So we should be careful about our units, our calculation. Then V must be defined 9.81. And I define the units for my reference, meter per second squared. Right. Is there, and x and all that. Okay. Then do while t is less than 10, t has been defined as 0. So I define the x coordinate, x is equal to v naught times cos of theta. It should be converted to radians, right? So I define pi by 180 and times t, right? So here I got the feeling that there must be pi defined somewhere. So pi and pi value, as I take 4 times a tangent of 1, 0. Right. So declaration. And then x value, y value is v naught times sine of theta times pi by 180. So in every calculation, this is going to be performed in this way. minus half. So I write it 0.0 divided by 2 times g value times t squared, which is t times t. And after this calculation, I require update update the time step. So t is equal to t plus, right? Update of time step when t is less than this one, this will be the situation. And before this one, we ask it to print the value, print in a usual way, write the value of t, print t value, then okay, this one, then print x value and give a spacing and then y, right? I have used a separated as a semicolon. Sorry, this is the exclamation mark, and then there will be the end end do end do, right? So t was initialized to 0 as, let's see whether 10 values are printed or not, right? And then we will further explore that thing. So save the program. The name I suggested was prog. It should be saved as a Fortran file in the right directory, projectile.for. Okay, so syntax has been highlighted, and let's see. CMD. I have to get to E directory CD, then G77, G77, and bin directory. So now G77 prog dot for, let's go prog dot exe. It seems I'm lucky enough not to have errors. It is blinking. Okay. The message is program has been compiled. Now we can call the exit file. And we have got the results, right? So x value starting from 0 and then 9, and correspondingly the value of y 7, and then it falls to -9. It means the time step needs to be shortened, right? And we don't have to go up to 10 because with this one it has become -370, right? So let's make this update. So let's get to the time step. Well, it said that at 4, it has get to -9. It has already hit the ground. If we started that one from the ground level, so it means I can afford a smaller step size, 0.1, and I shall go up to 3 or 4, 3.5, right, with the step of 0.1. And how to save that? Yes, save this one and then run it. Yes, but I have to compile it again. Compile and run. Run. So we have got many values, and we found at 3.5, almost 3.5, it is slightly above the ground, right? But you can see that this settlement is not that fine. We cannot copy this data from here, right? And develop the graph of the trajectory. So we have to control this output. So for this one, I'm going to detail something in this asterisk. So right here, well, so in conventional style, I can write a number here, label 5, 5, and whatever you like, label 5. But generally 5 is the default number for read statement. So 6 is default for printing. So 6, and then I can attach this 6 statement. And here I can write within 6 statement there is format statement. So with format I write 1x. Okay. The first value is time, right? I would like to write time. So for time, time is a real number. So I can say it's a real number. So floating point number, reserve 6 spaces. And out of 6 spaces, represent the decimal, 2 places for the decimal writing, right? Then I have the mark. So for this mark, I can say, okay, A2. Then I have X value. So I reserve X, say 7 spaces with 3 decimal places, right? And then again, there is exclamation mark. I write A2, that it is like alphabet or a character. And then Y again, I prefer 7.3. Now let's see the output now. The label and this one. CLS compile. If it means whatsoever I wrote was correct. So I have reserved these spaces, right? Let's run it. So now it is written in a bit elegant fashion. So you can pick the time values and you can see the X values and corresponding Y values, right? To copy this data, make a right click over here and it says mark, right? First mark this one. So, well, everything will be marked. So I take the mark from here, okay. Then again, make a right click. Control C is not going to work with the command bit, right? Oh no. For copying from the DOS, from the command window, you have to press the enter. See, for copy, there is the enter. So first mark the region and then press enter. Okay. And then you have to paste it in some Microsoft Excel sheet. Well, before that one, I generally do the pasting of the data in Notepad++. So everything has been pasted. And then from Notepad, I can copy column by column. And meanwhile, I generate a Microsoft Excel sheet. Okay. Wow, several windows have been opened. CF lectures. Excel sheet. File. Well, that is just to demonstrate that Fortran cannot produce graphs very quickly or with some very little effort. And the graphs are of low resolution. So it is good for scientific computing, however, not for graphics and others. For that one, you require another software. You have to export the data and then it is there. So from here, in this column, we write X, here Y, and here. Did I copy the data? No. I can copy from column to column, So press Alt and Shift. It is the column mode opened in Notepad++. So this column for X. Okay. 1, 2, 3, 4. Was it really the same? Okay. And then from here, again, Alt and Shift, and we can then copy the Y column. Okay, it has been generated. Now we can get the plotting done. So in Microsoft Excel, I prefer this type of plot, points and points joined with smooth curves. So then select the data, add a series, provide X values. So from the respective column, we can provide the value of X, and for Y, I can pick up the corresponding values from the respective cells. Projectile, right? So the trajectory has been explored, and it was very, very right? So then there are problems when the projectile will be at this height and will be at the other height, right? And here I have demonstrated in this program the format statement. Format statement control the number of spaces for printing. So F6.2, F7.3. So you can notice that some of the values were printed with the 2 decimal places, right? Time has been printed here with 2 decimal places, and here are 3 decimal places. 7.3. The whole spacing, the whole cells reserved were 7, and 3 were taken for the decimal printing. So with this one, I stopped the recording, and the experiment was successful. So always print outputs with the proper formats.